Today we will go one more problem regarding a principal stress calculation. That is, here they have asked in this problem, determine the principal tension at 0.6 meter from left support and 20 mm above centroidal axis. That is asked. Okay, 0.6 meter from the left support and 20 mm above the centroidal axis. There you have to calculate the value of principal stress. This is needed for the shear stress calculation. So we will draw a diagram, that is 120 mm width and 300 mm depth is given in the question. So I made as a diagram here, that is 8 mm at the center, it is 100 mm dip is given, so it is 20 mm at support. So I written in this fashion, and 0.6 meter AXX section I have taken. So 10 meter is a simply supported beam having a span 10 meter. Here y is equal to sine theta, that is equal to for a parabolic equation. Using a parabolic equation, that is, we wanted to calculate a vertical component of a stress, that is or shear force. You have to calculate y is equal to sine theta is equal to 4h divided by L square into L minus 2x, here the parabolic equation. So I will substituting sine theta is equal to 4 into 80. 80 is nothing but this h value. Okay, the cable, how much it is sagged with respect to the support. Okay, divided by 10 meter is given, so 10,000 square into 10,000 minus 2 into 600. So totally sine theta you will be getting as, after calculation, 0.028. Next we will move on, that is a vertical component. P sine theta is equal to, that is P is 300 kilonewton is given, substituted, and you will be getting as 8400 newtons. And then you calculate shear force at support, that is WL by 2, that is equal to, shear force is given 30 kilonewton per meter length, 10 meter is a span length, divided by 2. So this much is a shear force, that is 150 kilonewton, or 150 into 10 raised to 3. Now calculate net shear force, difference of those vertical shear force and shear force. So you will be getting as 150 into 10 raised to 3 minus 8400. So you will be getting as 141.6 kilonewtons. Next we will be moving for a shear stress calculation. This is a very important part here, because they are given to calculate shear stress above the neutral axis or centroidal axis 20 mm above. So that is what I hatched, that much portion. So this much section you have to consider under consideration, you have to do it. So 130 it will be, total it is 300 mm. So from the above the centroid 150, but I want above 20 mm, that is, so it is 130 mm and 120 mm, that will be a area. So we will be substituting for this formula. So tau v is equal to 141.6, that is you are getting from here, and 120 by 130 and 130 by 2, that means here to here distance. Y bar is nothing but CG of the section to the neutral axis. So 130 by 2 you will be getting this much, and plus 20, so totally you will be getting y bar, and BD cube by 12 multiplied by B. And next, that is tau v is equal to, you will be getting as 5.8 Newton per mm square as a shear stress you are getting. Next we will be move on, that is here, that is principal stresses you want to calculate. Fx is equal to P by A, that is equal to 300 into 10 raised to 3 divided by B into D, so 8.33 Newton per mm square. Fy is equal to 0 because vertical component is not there. So we will be going for F maximum, the formula as usual, and F maximum I will be substituting the things, all the datas, and F maximum I will be getting as 11.305 and minus F minimum. This they have asked here, they have asked to calculate tension principal stress they have given, so it is minus 2.975. So thank you.